So we have a 3-inch diameter cylinder turning an 11.3-inch cut. Cutting speed is 300 feet per minute. Cut time is 1.02 minutes. Calculate the tool feet in inches per revolution. So the first thing I have to calculate is the revolutions here. Our revolutions N is going to be what? That's cutting speed, yep. Remember, N is equal to 12 times the cutting speed over pi, right? Pi times diameter, there you got it. So 12 times 300 over 3.14 times 3. So 12 times 300 divided by 3.14 times 3. I shortened some things in my head there to make that work. 382.17. 382 RPM. So we got 382 RPM. We need to figure out what is that feed rate. Remember, time is equal to length of cut over the feed rate times the RPM. But we have here that the time is 1.02 minutes. Our length of cut is 11.3 inches. Over the feed is what we're looking for, and our RPM is 382. So to solve this, we are solving for F here. Couple of ways we can go about this. The easiest way is probably just to do this. Make it into a proportion. This direction, we've got 1 times 11.3, which is 11.3. In this direction, we've got 1.02 times F times 382. Well, 1.02 times 382 is 389.64 times F. So 11.3 equals 389.64 F. And we solve for F by divide by the 389. So 11.3 divided by that previous number, 0.029. And that's going to be inches per revolution is my feed rate. So just under 300ths of an inch. What do you think? Good stuff? Today we're going to talk about spur gears. And yes, this is going to tremendously stretch my artistic talent, so bear with me. So there we have our two spur gears going together. Now you'll notice we've talked about gear ratios before. This top one has 8 teeth, bottom one has 6. So this would, depending on where the power is coming from, either an 8/6 or 6/8 gear ratio. But what we want to talk about today is we actually want to talk about the parts of the gear itself, the sprocket itself. And of course, this part right here is the tooth. We've discussed that part a little bit. But there's a lot more in-depth pieces going on here than just that tooth. There's a lot of math behind that tooth to make things work together. Yes. First thing, of course, we know that we've talked about those teeth had to be the exact same distance apart, or they won't mesh. The way we calculate that, we have something called a pitch circle. The pitch circle is sometimes referred to as the working diameter of the gear. Because the gears mesh together, both gears aren't considered to go all the way out to the outside edge. So what we have is we have a circle like this that is partway between the end of the teeth and the inside of the teeth, like that, goes partway out the tooth. And we have a similar circle on the other gear. Those are what's called the pitch circles. Those two circles are exactly tangent at the meshing of the gears. So they don't go into each other, but there's no space between them either. The pitch of a gear is equal to the number of teeth, which we use N, number of teeth, divided by D, which is the diameter of that pitch circle. We call that the pitch diameter. For two gears to mesh together, they must have exactly the same pitch, because that pitch describes how far apart the teeth are. It's actually calculated in teeth per inch, is what the units are on it. Now, also within these teeth, you'll see a couple of things. First of all, you'll see that this tooth here does not touch the inner side of that gear. Now, there's that inner diameter of the gear. That inner diameter, that inner circle is right here at the base of the teeth, where the gear is solid. And then there's an outer diameter, which is out here at the tip of the teeth. But you can see that the outer diameter of one gear does not touch the inner diameter of the other gear. In other words, the tip of that tooth does not come all the way inside of that gear. Yep. That is called the clearance. You don't want a lot of clearance, because the more clearance you have, the more likely it is that the tooth's going to get snapped off. But you got to have some so that you don't get some sort of gunk in there that tooth binds in there, rams in there. So if I throw my pitch circle back in here on one gear, like right here, pretend that's circular. The part of the tooth that sticks out past the pitch circle, come on now, that's this piece right here. It goes out here. That is called the addendum. The part of the tooth that is inside the pitch circle. What's that? 2D. It's called the dedendum. These terms are all in your packet too, by the way. If you look at the top of page 247, there are some diagrams of these on there. So there are a lot of formulas that govern how these gears work together, or finding the different pieces of the gear. And it all comes down to our basic geometry. Starting at the bottom of page 247 there of your packet, you'll see there are tons of formulas. We already showed you this formula here for pitch. They give an alternative formula where P is equal to 3.1416. What do you think that number is? Pi, yeah. Pi is 3.14159, blah, 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 blah. We round that, they're rounding it to 4 decimal places instead of our usual 2, that's all they're doing. Pi over what's called the pitch. So the circular pitch. The circular pitch, PC, is actually defined right below it. The circular pitch is either pi over pitch. Yeah, they're reciprocals of each other, right? Or the PC can be given as pi times the diameter over the number of teeth. Again, number of teeth over diameter is the pitch. Diameter over number of teeth times pi is your circular pitch. So what we have here, 247 through 248, is a whole ton of formulas describing how you calculate all these different features of a spur gear from other known features. Now on 248, you'll notice there are some formulas that have asterisks beside them. Yeah. Like the addendum. Yeah, that whole section there, there's like 5 in a row that have that. What that is those formulas only apply to certain types of gears with a certain specific type of tooth. 14 and a half degrees. What that means is instead of coming straight out at a right angle from the circumference of the circle, it is tilted at 14 and a half degrees off of 90. And that's what involute means. And a full depth tooth means that they come almost zero clearance. Now, full depth does not mean zero clearance, but really as close as they can get to it. Yes. So there are 2 types of teeth you run into. You've got the square teeth. That all are very, very tight together. Then you've got angled teeth, the involute tooth. It's a little bit more like that. If you have bigger gears, you'll most usually have bigger teeth. You usually have involute teeth. If you have the smaller teeth, you usually have a straight tooth, a regular tooth, perpendicular tooth. I can't remember the name for those anymore. That's an involute, yes. So there's a couple of different angles we can take at this. We're going to be starting page 251. There's questions on these. And we're going to start out with simple ones. If you're told that the pitch is 10, and they want to find the circular pitch. Circular pitch is just the pitch divided by, actually, other way around, pi divided by the pitch, right? So 3.1416 divided by 10, or 0.31416. So there's an example of one where we just find the formula. We look at what we're trying to find. We're trying to find circular pitch. And we look for a formula that we're given the pitch. So we look for a formula under our group of formulas for circular pitch. We look for one that has the pitch in it. And that's the one we use. Similarly, you should do 3.1416. Or we could drop down to number 10. Number 10, we're given circular pitch. PC is 0.6283. We're given the pitch diameter is 8.400. Why did they go to 4 decimal places? Because they want to make sure we stick to our, if we are using our significant digits, their calculation doesn't get rounded incorrectly. So we're asked to find the number of teeth. So we look back, we find a formula for number of teeth in that table. Number of teeth can be pitch times diameter, but we don't have the pitch, we have the circular pitch. Or the number of teeth can be 3.14, it's the last one on the table. 3.1416 times the diameter divided by the circular pitch. And so that's the formula we're looking at. 3.1416 times 8.4000 divided by 0.6283. And we get 42. There's 42 teeth on it, yep. But if we were to keep going here, we'll run into problems. Like number 26. In number 26, we are given the addendum. .0857 inches. We're asked to find the circular pitch. If we look back at our table for circular pitch, you'll notice there's absolutely nothing for circular pitch. There's 2 formulas given. The first formula involves the diameter and the number of teeth, and the second formula just involves the pitch. None of those formulas involve the addendum. So rather than looking at the formulas for what we're trying to find, which is what we would normally start with, but we don't have anything there that works, we look for the formulas for what we're given. So we look for the formulas for addendum. Under addendum, we see that there is one that says the addendum A. Well, we don't have the pitch, though. We have the circular pitch. So it's the 0.3183. You got it, times the circular pitch. So here we couldn't find what we need. We looked in the formulas for what we were looking for, and none of those formulas had what we were given. So we go backwards. We look at the formulas for what we're given. Excuse me. And we see if any of those include what we're looking for. And we find one. So we're given the addendum and we're looking for PC. So we're kind of working backwards here, but it's going to get us to the same spot. So our addendum of 0.0857 equals 0.3183 times that circular pitch. And we'll solve by, excuse me, we'll solve by dividing by 0.3183. So 0.0857 divided by 0.3183. So we get a 0.2692. is that circular pitch. So you can see there's a case where we couldn't find a direct formula, so we had to go backwards. We had to backdoor it, go start with what we were given and work back to what we're trying to find instead of the other way. And it gets even worse. But wait, there's more, right? Number 34. We're given the number of teeth is 72. We're given the pitch diameter, which is D, is 6 inches. We're trying to find the addendum. Well, we're looking at formulas for addendum. And if the addendum is either related to the pitch or the circular pitch, but we don't have either of those. Look at the number of teeth. There is no formula in the number of teeth that gives us the addendum, is there? So we go to the pitch diameter, D. There's no formula in the pitch diameter that gives us, that has the addendum in it. Does that mean we're screwed? No. If we look at the formulas for the addendum now, what we're looking for again, now when we went through the steps, the first thing is to look at the formulas for what we're looking for and see if anything works out and it doesn't. The second step was to look at the formulas for what we're given and see if we can work backwards, and we can't. Our third step is to go back to those formulas for what we're looking for. One of those formulas for the addendum is 1 over P. Let's see if, with what we're given, if there's any way we can calculate P. So let's look at the formulas for P, the pitch. And we find that the pitch is equal to N over D. So we can use what we're given here, the number of teeth and the pitch diameter, to calculate the pitch. So we have 72 teeth over a 6.0000 pitch diameter, which is 12.0000 inch pitch, or not inch, per inch pitch. So yeah, our addendum then is 1 over the pitch, 1 over 12, or 0.0833. So you may have to do a little bit of work digging for these. Well, as you guys are aware, this country is stuck on a decision between staying with the standard measurement system and going to the metric system. We've already made up our mind 30 years ago that we were going to go to the metric system. Haven't necessarily agreed on when we're going to do it and how we're going to do it and how that transition is going to take place. It is slowly and eventually going to happen. So what's the equivalent to all this in the metric system? Well, that is the metric module system. In the metric module system, rather than pitch, we use modules. This is on 250, yes. The module of a gear is the diameter in, I believe it's in millimeters, yes, divided by the number of teeth. So if I have a gear, we're assuming if I just draw a circle for a gear, I'm not drawing the inner or the outer circle, I'm drawing the pitch circle. So that, say we have a gear that is 42.00 millimeters, and it has 14 teeth. It'll have a module of 42.00 millimeters over 14 teeth, which comes out to be 3 millimeters per tooth. We usually just say that's a 3 millimeter module. So what that means is if we do have the teeth on there, that from at the pitch diameter from the start of one tooth to the start of the next tooth is 3 millimeters. Or sometimes they'll say from the center of one tooth to the center of the next tooth is 3 millimeters. Same thing. Right? So you can see they have all those items then. Circular pitch, diametric pitch or pitch diameter, outside diameter, addendum, dodendum, hole depth, working depth, all that good stuff for the metric module system as well. So what I'm going to have you guys work on, starting on page 251, going up through page 254. There's 1 through 63, the odds. They'll talk about pitches and spur gears and modules. Make sure you get some of each. The first 20 or 25 are fairly simple, where you just look up the formula for what you're looking for and you find it. The next set, you've got to work them backwards. You've got to find the formula for what you're given and work backwards what you're looking for. Third set is you might have to go through a couple of different steps to get what you need. But make sure you work through them. The standard pitch is the most important here because that's what you're still going to be using. But try to do a couple from the metric module system because you're going to be seeing it. Right now, I'm sure you probably don't see much in the shop with it, but it's going to be there probably before your career is over. In the next 20 years, I would be willing to bet it's going to be